So the next talk is about climate change in Australia. So Dr. Sarah Perkins Kirkpatrick, I don't know if I've pronounced that right or not, but yeah. So she's affiliated at ARC Future Fellow and Climate Change Research Center at the UNSW. Hello, Sarah. She's also online. I hope we don't have any more audio issues, but if not, we will try to sort them out the best way we can. So yeah, we've got 10, 12 minutes and then 3 minutes for questions. Please go ahead.
Great, thanks for having me. I hope you can see my screen okay. Let me know if it's the wrong way around. So I'm actually based in Canberra now at UNSW in Canberra, and I'm also presenting from Ngunnawal country today. And I'm just going to give you a summary of climate change in Australia. I'm a climate scientist and I specialise in studying heat waves. So I'll touch on that a bit throughout my talk as well. And I'll just need to advance. Okay. So over the last 110 years or so, Australia's average temperature has steadily increased. So the globe has warmed by about 1 degree Celsius, a little bit over, since the turn of this century. However, Australia's temperature has actually warmed by about 1.4 degrees Celsius since 1910. Most of this warming has occurred in the last 40 to 50 years, so roughly from about 1970 or 1980 onwards. And as you can see, we are warming slightly faster than the global average. These temperature trends, they do have year-to-year variability, which I might touch on in the end if I have time, but they're also occurring on the overland, so at the atmosphere overland, as well as the sea surface temperatures. So it's not just something that's just happening overland. And land temperatures, so atmospheric temperatures overland do warm slightly faster than ocean temperatures, which is why we're seeing a slightly higher change in temperature relative to the global average. And what's causing this is the amount of carbon dioxide and other greenhouse gases that we have in the atmosphere. So these two graphs are showing on the left the cumulative the cumulative radiative forcing from all of the greenhouse gases we currently have in the atmosphere. And the figure on the right is actually showing the cumulative carbon dioxide concentrations, both for CO2 in itself, which is the blue line, and also CO2 equivalent gases. So this is including the other concentrations of other greenhouse gases relative to what they would be if they were carbon dioxide. So in terms of carbon dioxide, we're actually currently sitting at around 410 parts per million. But if we're looking at the total equivalent from all greenhouse gases, we're actually sitting at around 510 parts per million. When it comes to future change, how the future does play out depends on our emissions pathways. And there's a lot of uncertainty around this because a lot of it actually comes down to politics, which I don't really have time to talk about. But, you know, if you ever want to hear my views, I'm happy to sit down with a few hours and discuss it with you. So if COP26 pledges are met, and that's the climate conference that recently happened in Glasgow, global warming temperatures will warm by roughly 2.7 degrees Celsius by the end of the 21st century, and average temperatures will be slightly higher for Australia. There is ranges around this, so we could even warm by more or we could even warm by less, but it really comes down to what pledges are made and those pledges being kept by global nations, not just Australia, but by other countries as well. So you might be thinking, well, so what? An average temperature change of less than 3 degrees actually sounds really nice. This certainly sounds nice where I am at the moment because the weather's pretty terrible. But that's not what it's just about. What this graph is showing here is we only need a small change in average conditions, so average temperature, to see a really large increase in the frequency and intensity of climate extremes, and that especially includes temperature. So you don't need a large change in average temperature. If we do have a large change in average temperature, it's really catastrophic for extreme events. And climate change is really effectively felt through the changes in extreme events. So for example, flooding, heat waves, tropical cyclones, droughts, that's where climate change really embeds its fingerprint on society. So it really goes without saying that the more that we will warm by, the more frequent and intense climate extremes will be. So this figure has actually come from the most recent IPCC report, which is an excellent resource, by the way. And what it's showing is basically, everywhere of the world, extreme events that were, really extreme in terms of heat previously will occur much more often. The same goes for precipitation and also droughts, but those changes are slightly less than what we expect for a heat extreme. So really at the moment, we're really predicting really hot conditions, slightly heavier precipitation events, and droughts that are longer and more intense as well. So for the next few minutes, I'm going to concentrate on different types of extremes that we feel here in Australia and how they're changing both presently and in the future. And of course, naturally, I'm going to start off with heat waves. So on the left, we have 6 different figures that are showing changes in different types of heatwave indices. And basically everywhere you can see over Australia since 1950, there's been quite significant changes in the number of heatwave days we get in a season, how long these heat waves last for, the number of events that we may see in a season, the cumulative heat that all these events generate within a season, how long the heatwave season is, and how early we actually see the first heatwave event. And that's a pretty strong signal for most of Australia. Different regions do experience different rates of change in these indices, which is kind of what the figure on the right is showing. But for the large majority of the country, these trends are very significant and very real. And I actually did a study about 10 years ago that looked at trends up until around about 2010. And I can tell you they've actually intensified over the last 10 or so years, which is quite concerning. So this figure is a part of a paper that I'm currently writing. So I would really appreciate if it's not tweeted or shared on social media in any capacity. But I just wanted to highlight that the choices that we made at COP26 really matters for heat waves. So you can see here, this tiny little dot, which is blown up in the inset, is the observed heat wave that we actually experienced in the 2018-2019 summer. So this isn't even Black Saturday, it's the summer before that. And as you can see, regardless of the emission scenario that we follow in the future, which is what these different colours show, pretty much every heat wave we're going to see in the future, so everything right of this dot and everything higher than this dot, is going to be more intense, it's going to cover more area, it's going to be longer, and it's going to generate more heat overall. So what this really shows is what we've experienced in our recent living memory is really nothing compared to what climate change can bring. Most of these really extreme heat waves do occur in the higher emission scenarios. And the kind of good news out of COP26 is SSP 585 isn't really likely anymore. It's probably going to be somewhere between 3.7 and 2.45. So that's the good news. But we're still seeing some really extreme heat waves under those emission scenarios. Okay, so on to rainfall changes. So the observed rainfall changes over Australia do depend on the season and the region that we're looking at. So rainfall does vary very highly year to year, especially due to things like ENSO, where we are just in a La Nina pattern now. But there has certainly been a decline in cool season rainfall over most of Australia, and that's been shown to be due to climate change. The wet season rainfall over Northern Australia, however, has been shown to be increasing in the last 20 or so years. So you can see here that rainfall in the northern parts of Australia that typically experience a monsoon, that the amount of rainfall they experience during the monsoon has increased. So there are some sort of rainfall changes there. It's hard to say how rainfall over all of Australia as an average is changing, but there's certainly lots of different regional changes that we can detect. So unfortunately though, which is a bit of bad news, is rainfall extremes are going to become more intense. So the rainfall that we experience over different parts of Australia that falls during extreme events will intensify. So the different colours here represent different experiments. The blue is the medium emission scenario and the pink is a high emission scenario. And you can see here that regardless of the region that we're looking at, the amount of rainfall that we experience during a daily event and the return level of something that occurs once every 20 years is actually increasing. So when it rains, it will be heavier. And that's reasonably significant over most of Australia, especially as we move towards the end of this century. And unfortunately, on the other end of the spectrum, droughts are going to become more intense too. So we've got different droughts are a tricky beast. They come in different categories and different durations and even different types of droughts, which I won't go into. But what this figure is showing that the really severe droughts, labelled here as extreme, are going to increase. So we're going to see more of these events within a 20-year period at the end of this century. And on top of that, the extreme droughts are also going to increase in their duration. And that's, especially in this case, it's relevant to the emission scenario. So the worse the emission scenario, the longer these droughts or these extreme droughts will occur for. And so lastly, in terms of extreme events, I just want to talk about fire changes as well. As I'm sure those of you who have been in Australia during Black Summer, it's quite present. I'm sure it's certainly not a summer you'd forget easily. And what we're actually seeing is the Forest Fire Danger Index, which measures the fire conditions on the ground, is actually increasing over much of Southeast Australia and other parts of Australia too. But this is especially occurring in spring. So that's where a lot of some of the Black Saturday bushfires actually started, was in spring. And the number, this graph here is showing that the number of dangerous fire weather days over Victoria especially is increasing during the spring time of year. And in part, this is due to that decline in rainfall that I talked about earlier, and also the fact that the fuel, which, you know, for example, trees, etc., that light during bushfire, are much drier on heat wave conditions, during heat wave conditions. And heat waves and a decline in rainfall are very tightly linked. So all of these extremes are kind of combining together to really enhance the bushfire conditions. Unfortunately, not a good news story, but future fire weather will be worse, and especially in spring. These two graphs are showing changes by halfway through this century on combining two different types of fire indices. Changes in moderate fire weather is significantly increasing over much of the southeast, and more extreme fire weather is still increasing, but slightly less so. But certainly altogether, fire weather will be worse as we move really over the next 40 or 50 years, which is not good news for things like events like Black Saturday. So in the interest of time, I might just skip over that slide. So I've only really touched on 4 different types of extreme events, which is how, you know, as I mentioned earlier, climate change is actually imprinted in the extreme events. So this is what we really feel as the climate is changing. But there are also other changes. So we are obviously seeing that increase in global temperature. Sea level rises are also rising. We're seeing more marine heat waves, which are fascinating, but also frightening. And unfortunately, I couldn't talk about those today. I've talked about heat waves. We're also seeing fewer tropical cyclones, but those that do occur are actually in higher intensities, and combined with sea level rise, they can really generate intense and dangerous storm surges. And as I mentioned, we're seeing cool season rainfall decline, heavier rainfall when it does fall, and also longer fire seasons and more dangerous fire weather. So if I do just briefly have time, I just wanted to touch on what actually happened in COP26 and my views about that. So our carbon budget is really finite. If we want to limit climate change to, you know, 1.5 or 2 degrees Celsius, and I would really argue that 1.5 is off the cards, we need to take drastic and serious action and take that now. So if we were to limit global warming to 1.5 with an 85% chance, we basically have to have net zero emissions as a globe by 2026. And that's why I think it's impossible. That's simply not going to happen. On top of that, net zero by 2050 really only gives us a 50% chance of stabilizing global warming to 2 degrees Celsius. So this isn't also really that great. There's a lot of emphasis on net zero by 2050, and I get that and I support that. But that still doesn't lock in limiting global warming to 2 degrees Celsius, which is really, you know, quite concerning. And you can see here on the map, the year at which different countries are saying that they'll be net zero. And not all of them are actually saying by 2050 or before. Some of them are actually a bit later, for example, Russia and China, that are saying 2060. And that really does impact how much the globe will warm by, which is what pushes us up to the 2.7 range by 2100. And just to add, unfortunately, with the Australian plan, there's really nothing groundbreaking or even useful there. It's all really a PR stunt. They have put a lot of emphasis on new technology that hasn't even been invented yet, which I think is pretty concerning. And also on carbon and capture storage, which really is trying to give them a free ticket to still emit and transport greenhouse gases out of Australia. Now, carbon capture storage technologies are actually 3 times more expensive than green energy solutions. And we already have the ramp up of the green energy technology that we need. It just needs a bit more investment and a bit more deployment to actually make it feasible for everyday Australians. And I just wanted to add, this is my very last slide, that when you're talking or thinking about climate change, don't mix it up with climate variability or weather. Coming from Canberra today, the weather is pretty miserable. It's actually been raining basically all of November, and it's also been really cold. But that doesn't necessarily mean that climate change isn't happening. We're just experiencing an exceptionally wet month for various different reasons because of the different mechanisms that cause and drive climate over Australia. So just be aware that, you know, there are different mechanisms that cause the climate, but this doesn't, you know, this may only negate the climate change signal for a year or a season. It's definitely still there, and we'll certainly see that play out in the coming years. So I'll leave it there, and I'm happy to take any questions if there's time. And apologies for talking fast. Australians do it as well.
Very interesting. Is there any questions in the audience? I think we are we allow only one. Just... A question.
Thank you. Thanks, Sarah. Is there any good news? Is there any good news? So like extremes in cold extremes.
look, that's a good point. So there is a decrease. So with that shift of the temperature distribution to the right, we're seeing that increase in extreme hot temperatures, but that also does mean a decrease in extreme cool temperatures. I guess that depends on where you live. If you're living in really cold climates and don't have the ability to, survive in those cold climates, a shift towards the right and those warmer temperatures is probably a good thing for you. But in places that are already quite hot and you're shifting towards even warmer temperatures, that's definitely not good news. So it does depend where you are, but I would argue that the news is mostly not good for most places.
Thank you.
Concerning situation we're facing with the climate change. Thank you very much, Sarah. I think we don't have any more questions, but we need to go and move on onto the next presentation. Thank you very much.